Okay, here are a few more trig identities to practice with. So I'm going to put mine in a t-chart just because that's my preference. Keeps them separate. Actually, I need a bit more room on the right than the left. All right, so let's put the t-chart here. Okay, so on the left side we have cosine squared x, so not much to do there. On the right side we have sine squared x plus 2 cos squared minus 1. Okay, so when I'm looking at this, everything's in sine and cosine, so that's fine. On the left we have cosine and only cosine. On the right I see this sine squared that I don't really want, and the 1. So I'm going to replace the sine squared with 1 minus cos squared. So I want it with something with cos in it instead of sine. And then what I'm going to do is collect like terms. So 1 minus 1 is 0, so that gets rid of the 1. And then minus cos squared plus 2 cos squared is just 1 cos squared. So all I'm doing here is collecting like terms. So I replaced sine squared with something with cosine because I didn't want the sine squared because there wasn't one on the left, so I don't want one on the right, so I wanted to get rid of it. So I replaced it with something in terms of cos squared. So sine squared equals 1 minus cos squared, and then all I had to do was collect like terms, and then the left side equals the right side. All right, let's see what we have here. So on the left side we have secant squared x plus cosecant. And on the right side we have secant squared x multiplied by cosecant squared x. So nothing is in sine and cosine, so I'm going to switch them over. So secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. And the same here. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. So on the right, I can just multiply. So numerator 1 times 1 is 1. Denominator, I get cos squared times sine squared. On the left, we are adding fractions, so we need a common denominator. So the common denominator would have to include cos squared x and sine squared x, which means this term would have to get multiplied by sine squared, both top and bottom, and this one would have to get multiplied by cos squared. So in the numerator, I get sine squared plus cos squared x. And then looking at the right, I see the numerator is 1, and I know that sine squared plus cos squared equals 1, so I will replace that. And then the left side equals the right side. In this example, let's see what we got here. So we've got tan squared x minus sine squared x. And then on the right side, we have sine squared x times tan. So I will replace tan. Tan is equal to sine squared x over cos squared x. And I'll do the same over here. Tan equals sine squared x over cos squared x. So on the right, I'm just going to go ahead and multiply. So in the numerator, I get sine squared times sine squared would be sine to the power of 4. Just like x squared times x squared is x to the power of 4. Over here, I'm going to get a common denominator. So it would have to be cos squared x. So this one needs to be multiplied by cos squared x. So that gives me sine squared x minus sine squared x cos squared x all over cos squared x. So when I look on the other side, I see that we have the same denominator. Both left and right side have a denominator of cosine squared x, so that's good. In the numerator, on the right side, we only have sine, and on the left side, we have sine and cosine. So I don't want this term. I don't want this cos squared, so I'm going to replace it. So I want to get rid of things I don't want. Remember, you have to have a reason for changing something. So 1 minus cos squared equals sine squared. 1 minus cos squared equals 1 minus sine squared. So I'm going to replace that. And then I'm going to expand these brackets. So I'm going to multiply sine squared times 1 and sine squared times sine squared. So sine squared times 1, and then minus sine squared times minus sine squared is plus sine to the 4th. And then I see that sine squared minus sine squared is 0. So we can collect like terms. And that will leave me with sine to the power of 4. Now I get left side equals right side. Okay, in this example, on the left, we have sine theta plus cos theta all squared. And on the right, we have 1 plus 2 sine theta cos theta. So sine theta plus cos theta is squared. So I'm going to write it out twice. Don't forget that you have 4 things to multiply, not 2. So don't think that it's just sine squared plus cos squared. We have to multiply sine times sine, which is sine squared. Then we have to multiply sine times cosine. Then we have to multiply cosine times sine. And then we have to multiply cosine times cosine. So we have 4 things to multiply. So we've got like terms here. We've got 2 of those. And then when I check the other side, I see that both sides have 2 sine theta cos theta, but on the right side we have a 1, and on the left side we've got this sine squared plus cos squared, but I know that equals 1. So I will replace sine squared plus cos squared with 1, and then the left side equals the right side.